So, I think we mentioned this already, right. So, testing influences quality, right. If the test is not thorough, if the test is not good, then obviously bad products will get sold to the customer, right. So, there is in any company there will be what is called as quality control. Okay. You may have heard about this term, quality control. So, there is a quality control department. Okay. See, the same company may be manufacturing a number of different products. Okay. So, they may be manufacturing product number 1, product number 2, product number 2755. There may be so many different products they make. Okay. Each of them may be made in millions and millions of them. Okay. And these are all being tested, right. And the products which fail in each of these, right. So, they will have to be labeled and sent to the quality control department saying that these parts of this particular product P1 they have failed tests. Okay. They may even tell you what tests they failed. So, test number 1, test number 3 and test number 45, all these failed for this particular product 1. P11 means the first device to be tested in product 1. P1 let us say 49, this one failed, test number 3, test number 52. Okay. So, this kind of information will be received by the quality control department about all the products that they make and all the individual devices that failed, right. And they had to analyze this information and try to understand what could be the root cause. Okay. We call about we use the word root cause analysis. Okay. So, to give you an example that you may better relate to, in a college there may be a number of courses, right. There may be a course on DSP, there may be a course on digital design, there may be a course on analog design and so on and so on. Okay. And there may be a number of students who are taking that course, student number 1, student number 2 and so on and so on. Okay. Each student may pass some of these examinations and they may fail some of these things. Okay. So, the there may be a quality control department, okay, or each department may be responsible for its own quality control. There may be a committee, there may be a small team that looks into how many failures are there in DSP, how many are there in digital design, analog design, right. And they have to analyze this information and understand what exactly could be wrong, right. Is it because the syllabus was changed, upgraded, textbook that was selected was a very difficult textbook? There may be several reasons, right, and they have to understand the root cause, okay, and that root cause may have to be fixed, and after that it is expected the quality will improve, and meaning the number of failures will come down, right. So, that is what is the root cause analysis, right. So, testing, as you can see, plays a very important role in improving the quality. Okay. And in order to achieve that quality, the amount of resources that we spend on testing, okay, we must try and minimize those resources, right. Testing is expensive, as you possibly guessed by now, right, but we must try to optimize that cost. Okay. I have also mentioned to you about reliability, especially in sectors like automotive, industrial electronics, defense electronics or medical electronics. Okay. So, we need to understand that test plays a very important role in the reliability also. Okay. We will study a little bit more about this, right. This is more of an introduction. So, we will get into more details about things like reliability later. Of late, there are two more terms that we talk about. One is called safety and the other is called security. Okay. Safety, right. I may have mentioned the word safety in the context of automotives, right. See, if the product is likely to fail, right, any product is likely to fail, right. I think you by now understood that aspect, right, because the ICs or other products that we sell, they are all subject to what is called as aging. Okay. So, over a period of time they will fail. The aging can be sort of accelerated because of things like temperature cycling. Okay. So, if temperature cycle, what is the temperature cycle? You heat and then you cool, you heat and then you cool. Okay. So, when you take a metal wire, right, and you heat it and then you cool it, and you heat it and you cool it, over a period of time it may start developing cracks, okay, and as a result it may fail, right. So, understand that the product, right, that we have sold to the customer will be expected to fail at some stage or the other. Okay. And if it fails within the life time of the device, then the company which sold the product is liable. Okay. They can be blamed for selling a product which did not meet the requirements. Okay. It may lead to a legal battle, right. So, safety is related to things like, see, suppose the car uses some electronics and it is an electric vehicle and there is a speed control. Okay. There are motors whose speed is being controlled, right. So, there is a accelerator and there is a brake, right, and people use this to control the speed of the vehicle. So, imagine that a vehicle begins to accelerate even without the accelerator being pushed. Okay. Why is it happening? We do not know, maybe it is some IC which is misbehaving, or maybe it is a software issue. Whatever be the reason, it is a safety consideration, because the person who was driving did not intend to accelerate, but the vehicle is accelerating all by itself. Okay. And today a lot of software is controlling all these functions in vehicles. Okay. So, you may have heard about the term software defined vehicle, SDV, software defined vehicle. Okay. A lot of things inside our vehicles today are being controlled by software, and some of them are based on things like artificial intelligence, neural networks, learning. Okay. So, imagine that there is some software which decided that the vehicle should go faster, even though it was not the right decision from a safety point of view, resulting in an accident and so on. So, you will find, if you search the literature on a search engine, you will actually find there were such incidents that have happened. Okay. So, there was an incident earlier where a particular manufacturer of a car had to face a lot of legal issue because the car accelerated without the accelerator being pushed, resulting in an accident, and I think in that particular incident there was even a death, right. So, if you search the internet, you will find a lot of stories like this of accidents that may have happened because of a electronics component which misbehaved or a software that misbehaved, right. You may have heard that how to improve things like safety, right. What would you do, for example, if you wanted something to be done in a very safe manner, right. When you design, you build in some sort of redundancy, isn't it? That is the answer I was looking for. Okay. Suppose you wanted to send some information from A to B, okay, and you know that there may be impediments on the way. Okay. It may the information may not get delivered because of various problems. Okay. So, what would you do? You will try to also have an alternate maybe path, okay, and send the information in two different paths. The chances that it will fail in both the attempts is very less. Okay. So, we try to use redundancy in our everyday life when we have to worry about safety, whether we will be succeeding in this particular way of doing things. If we believe that is the case, we try to have a second alternative. Okay. In the same way, you may have come across companies that use a lot of electronics in their cars, right. For example, Tesla is a company that sells self driven cars. Okay, it is an electric vehicle, it can drive itself, right. Now, how do you think that software that drives itself, that drives the vehicle has been designed, right. It is after all going to run on a certain processor, right. Now, the processor, if it fails because of some reliability issue or something like that, then we are in real bad situation, isn't it? The car is driving itself, and let us say the processor experiences some sort of a failure. Okay. So, that is a dangerous situation. So, what companies do is they try to duplicate the processor. There will be two different processors. Okay. This is called as redundancy, hardware redundancy. We have used two processors in place of one in order to make sure that if one of them fails, the other one is available. So, that is an example of redundancy, right. Now, how do you find, how does one processor know that the other has failed, right. So, even though we sold the product to the customer, right, testing must continue. That is the point you have to understand, right. Earlier I mentioned to you, right, that there are three things: there is design, there is manufacturing, and there is testing. Okay. I mentioned this to you, and at that time what I mentioned is testing is done after manufacturing, and that is sold, the products are sold to the customers, right. So, when you buy a laptop, right, it was tested for defects and it was sent to the market, and now you have purchased it, right. It does not mean that the laptop will not have any more faults. It may develop faults newly, it may develop some difficulties over a period of time. So, if the laptop shows any signs of malfunction, then you must do your own tests. So, tests must continue. You may have done this, right. When you boot the laptop, many times it gives you the option to do some testing. Okay, you may have tested the memory of the laptop, you may have tested the audio, microphone, speaker, etc., etc. Right. For example, when you join a call, right, when you are setting up maybe a WebEx or a Teams call or something like that, you may have seen that they give you the opportunity to test the microphone or the speaker and things like that, right. So, these are tests that happen at the customer side. So, going back to the example of a car, right, the electronics in the car was tested at the time of manufacturing. After manufacturing they were tested and everything was good, but while it is being used, maybe it developed some sort of a defect due to a reliability issue, right. And as a result, the chance that both of them will develop the same defect is very low. Okay, that is a sort of a tenet on which all of this is built. Okay, if both of them develop the same fault at the same time, then nothing much can be done. Okay. Sometimes for this reason they may also use 3 processors or 3 electronic modules. Okay, that is called as triple modulo redundancy. Triple modulo redundancy. Okay. So, if you have used 3, then you can use a voting system, right. If the answer given by the first processor is let us say 55, this is saying 49 and this is saying 55, okay, then you take this as the correct answer. Okay. So, voting is used 2 out of 3. Okay. So, in this system which I showed earlier, there are 2 processes. Okay. Now, when they produce results, we can each of them could be testing the other, okay, to verify whether the other one is doing the right thing or not. Okay. So, occasionally if it is found that this processor is not producing the correct result, the other one can sort of shut that down and say that I am going to take control. Okay. So, what in essence I wanted to convey was that testing continues in the field. So, it is called in field testing. What is in field testing? Even when the product has been sold to the customer, the product continues to be tested. For example, it can happen when you ignite the key, when you ignite the car. there is an ignition, right? In electric vehicles, of course, there is no quote unquote ignition, but you still turn a key. So, at that time some tests may have to be done, and the system will sort of test itself to verify whether it is good to go. Okay. If it finds a problem, it will possibly come back and say that, sorry, I am not safe to go. Okay. You must take me to a repair shop and get me repaired. Okay. So, testing continues in the field as well. Field means after it is put to use. Then there is the aspect of security, right. What is security? See, the systems that we use, right, today we are placing a lot of them on the internet, right. The car is on the internet, the TV is connected to the internet, your mobile phone is connected to the internet, your laptop is connected to the internet. So, virtually, I would possibly say that, a lot of devices are now on the internet, right, which is good, right. You may have heard about Internet of Things, right. So, all these guys are on the internet. Okay. So, for example, there may be a camera which takes pictures of the baby in the cradle, right. There is a cradle, there may be a baby care center somewhere, and the baby is in the cradle, and the pictures are taken, right. And because of the camera is on the internet, it is able to send the pictures to maybe a cloud, and parents can periodically look at those pictures to see how their baby is doing. Okay, because the parents may be working, and they are worried about their child being in a daycare center, and they want to make sure that the baby is fine, especially if the baby has been sick or something like that, right. So, every device, whether it is a car or a laptop, camera, TV, refrigerator, today it could be on the internet, okay, and it could upload data to the internet, and you could analyze that data on the internet to see whether any intervention is required, etc., etc. Okay. Now, because you are putting the device on the internet, you are also making it vulnerable to hacking. Okay. So, people may be able to hack into that device and corrupt the data that it is putting up, right, or making it to fail, okay, providing false information to that device, corrupting the data that goes to the device, and as a result causing it to fail. Okay. This may be something intentional, okay. Somebody may have done that intentionally in order to achieve some sort of a goal. Okay. So, for example, you may have come across situations or you may have read news articles about a car being sort of hijacked, meaning not that in person somebody will come and hijack the car, but the controls of the car have been taken away by a hacker. So, in other words, that car is no more in the control of the person who is inside the car, it is being controlled by somebody else. Okay. So, this is a security threat, okay, and it is something which we have to deal with, right, especially if it is maybe the some very important person is inside the car, maybe a very important political leader is in that car, or some company's leader is in that car, etc., right. the security becomes a very important feature, right. You may have also come across situations where terrorists have used vehicles as weapons, right. So, drones, vehicles, they have all been weaponized, right. So, it is an important aspect to ensure that the car is secure, vehicle is secure. The same is true for robots that are used in the industry, right. So, how does that security really work, right? Sometimes they plant what are called as Trojans, okay. A Trojan horse, right. You may have heard about what is called as a Trojan horse. Okay. So, there is a story about the Trojan horse, you may have come across that, right. So, there was a war between the Romans and the Trojans, and in order to sort of defeat the enemy, right, a big horse was built out of wood, okay, and the army left that horse and left, okay, left in their boats, right. The people, Romans, were watching that the Trojan army was leaving, okay, and they thought that they had won the war. They came out and they found this big horse, right, and they didn't know what it was. They thought it was like a gift that these guys left behind, right, and they wheeled that big horse into the city, right, and what was really happening was inside the horse the soldiers were hiding, okay. So, they came out when everybody had gone to sleep, and they took over the city, right. So, it's a story, right, that tells you how one can insert a attractive looking thing like the horse, right, and get into somebody's system. Okay. We all download applications, isn't it? We find some interesting game and we want to play it and we download it, right. But inside that game maybe there is a Trojan, okay, which is doing some of the other things which are not safe. It may be stealing our data, right. So, we refer to such a thing as a Trojan. Okay. There are also some of these softwares can result in they can duplicate themselves, okay, and they can sort of consume all the memory in the system and cause it to fail, right. They may also prevent a particular device from being used, right. So, in our laptops we may have so many things, right. We may have speakers, we may have touch screen and so on. So, security failure will cause maybe it will not allow us to type anything, maybe it will not allow us to use a speaker, things like that, right. Imagine such a thing happening in a car or something like that, or in a robot, right. That could cause a serious issue, right. That could that could result in accidents and things like that. So, the difference between safety and security is, in security it is intentionally being done, okay. It is not something that happened because of aging or anything like that. It was intentionally planted. It was an attack, okay. So, some people use the word cyber attack, okay. So, even we have to periodically test the memory, we have to periodically test our hardware devices to see whether there are any such Trojan horses that have been planted, some bots, okay, or software elements have been inserted in order to carry out these kind of attacks, right. So, hardware security is becoming a very important topic today, okay. And elements of hardware testing are very important in dealing with the security, right. So,